Okay, let's take down this example. A steel rod is 900 mm long. A steel rod is 900 mm long. Its two ends are 40 mm and 30 mm in diameter, and the length of each rod is 200 mm. Full stop. The middle portion of the bar is 15 mm in diameter and 500 mm long. Full stop. If the bar is subjected to an axial load of 15 kilonewton, find its total elongation. Find its total elongation. Find its total elongation. First thing first, list out the given parameter, right? Now, observe, this question is a bit different from this, right? Because they said the total length of a steel rod is what? 900 mm long. We now have its two ends, right? We are giving the parameters for the two ends. We are also giving for the middle, meaning that the total length, which is 900 mm long, it means it is sectioned into three places. We have section 1, we have section 2, and we have section 3. All right, let's get it done. Comes to diameter. When it comes to diameter, you know, the idea of diameter is that one section is bigger than the other. You know, the two ends of the section, the diameter are given to what? 40 and what? 30. One is 40, one is 30. While the middle one is what? Is what? 15, right? So drawing the illustration, giving that question, the illustration for that question, we have this is what? The two ends of its diameter are what? 200. They are 200 mm in length. What are the diameter now? 40 and what? 30. This is A. Okay, the total length. The total length is what? 900 mm. That's A, B. This is C, this is D, right? A steel rod of what? 900 mm, right? Its two ends are what? 200 mm in length. From A to C is what? 200. This is 900 mm. The total length from A to C is what? 200 mm. From D to B is what? 200 mm. Then C to D is what? 500. The addition of this subtracted from this will give us 500 mm. This is 500 mm, right? What are we giving again? The diameter of this place is what? Call this section 1, call this section 2, and call this what? Section 3. The diameter of the two ends are given respectively to be what? 40 and what? 30. Alright. This is 5 is what? 40 mm. This one is what? 30 what? 30 mm. What about the middle portion? 15 mm. I believe you know why I'm using 5. You are in engineering student, of course. 5 diameter, right? What else? Axial load. We are giving axial load now. Is it compressive or tensile? It was not stated, right? Okay, let's go with tensile now. Tensile, who can tell me what will be the nature of that load? Will it be something of will it be push or pull? Pull. If I'm going with tensile, it will be pull. What if I'm going with push? It will be what? Okay. Let's say we have this now. Let's say I have this, and I have and I have this. Call this one, call this 2. Now, if I'm going with pull, which one will I go for, 1 or 2? I'm going with, I said I'm assuming the force now to be pull. Will it be 1 or 2? 2. I'm going with this. Meaning, in my diagram here, I have the force to be in this nature, and the magnitude of the force is given to be what? 15 what? 15 kilonewton. This place is also what? 15 kilonewton. What else? We are asked to find the what? Total elongation. Find the what? Total elongation. That is change in length. Now, when it comes to question like this, it means that we said we have section 1, we have section 2, we have section 3. Abi? Now, it means that we are going to get the value of the change in length in section 1, get the value of change in length in section 2, get the value of change in length in section 3, then what? Sum it up. Right? But there's a way we can do that. There will be a better way, unlike we doing it separately. Now, we said that change in length, we said change in length is equals to what? Force times length all over what? Area times what? Young modulus E, right? Now, for section 1, the change in length in section 1 means that F is constant. L1 all over what? Area is also constant, right? Are you sure this is the formula for change in length? Yes. When we say that force is the formula, okay, we said F is constant, area is also constant. Sorry, area is not constant. Don't forget, area deals with the cross-sectional, it deals with the diameter now. It's not constant. Young modulus is constant. Now, for section 1 now, this is the formula for change in length of section 1. Abi? For section 2, change in length of section 2 will be what? F L2 all over what? E is constant times what? A2. Then for section 3, now what will be the change in length for section 3? That will be what? That will be FL3, that is the length in section 3, all over E what? A3. We said for total elongation, it is the summation of change in length of section 1 plus section 2 plus section 3, right? Now let's add this up. Total elongation implies that FL1 all over EA1 plus what? FL2 all over what? EA2 plus what? FL3 all over what? EA3. Observe. Force and young modulus, they are constant. S factorize. We have that the total elongation is equals to F over what? E, all into bracket L1 over A1 plus L2 A2 plus L3 over what? A3, right? From here, it means in section 1, we have to get the ratio of what? Section 1, we have to get the ratio of what? L over A, right? Section 2, we have to get the ratio of what? L over A. Similarly, for section 3, we have to get the what? Ratio of what? L over what? A. Alright, from here, is there any conversion here? We are giving young modulus to be what? Newton per meter square. Giganewton per meter what? Square. Meaning, I'm working in what? Meter. Hence, I need to what? Convert. Right? Okay. From section 1, length is what? You know, the task ahead of me now is to get the ratio of L to what? A. Meaning in section 1, I need to get the length and I need to get the area. And we know for area is given to be, formula for area is what? What's the formula again? Okay, pi d square all over what? 4. Alright, from section 1, the length is given to be what? 200 length from A to C. 200 what? mm. 200 mm. Hence, in meter, it will be what? 200 times 10 raised to the power of minus 3. Then what do we have? 0.32 meter. Okay, the area, using this formula, it means pi, or first, the diameter of section 1 is given to be what? 40 mm. Right? Then in meter, what do we have? 0.04 meter. Now let's get the area. Using this formula, we have that pi open bracket 0.04 square all raised to the power of what? 4. Then this should be equals to what? 1256 point what? 1256.64 meter square, right? So let's get the ratio. So therefore the ratio of L to A in section 1.
Sorry. That's a millimeter square.
In what?
This is a millimeter square. The area is a millimeter square. So
No. The area is a meter square. Okay, use 40. No. Go with 0.04. 1.2568 times 10 raised to the power minus 3 meter square. Okay. Now let's get the ratio. Let's get the ratio of L to A in section 1. It implies that we have the length to be what? 0.2 divided by 1.2568 times 10 raised to the power minus 3. What do we have? 159.134. Let's talk about 134. 134 what? What will be the unit now? What will be the unit? Okay, it has no specific unit since we want to get the summation. Alright, now section 2. For section 2, we are giving that L, section 2, this is section 2. From your illustration, this is section 2. And section 2, this is the length. CD is what? 500 mm. Right? Converting 500 mm to meter, what do we have? We have L2 to be what? 0.5 meter. Okay, what about the diameter? The diameter is given to be what? 15 mm. Converting 15 mm to meter, what do you have? 0. 0.015 meter. Right?
Yes, sir.
Now let's get the area using this formula. We have that area at section 2 is equals to what? Pi open bracket 0.015 square divided by what? 4. What's the value? What's the value? Let's get the value. What do we have?
0.01178.
Are we all going with that? 0. Please let's confirm. Press our calculator. What do you have?
Square. 1 square. 1.767.
1.767 times 10 raised to power minus 4 what? Meter square. Meter square. We've done for section 1 and what? Section 2. Now for section 3. Okay, so we are here to get the ratio of length to area in section 2. You are still in section 2. Continuation of section 2. We want to get the ratio of the length to area. What's the value for the length? 0.5 meter divided by 1.767 times 10 raised to power minus 4. What do we have? 2829.054. Is that all? Then no specific unit as well. Moving to the next section, section 3. Section 3. Alright, let's do this together. Section 3 will be what?
0.2 times by area.
All 3 is equals to what?
That's 200
200 what? Give me a meter now. Let's work in meter. 0.2 meter. The diameter here is what? In meter. 0.03 meter. Now let's get the area. Using pi d square over 4, we have pi open bracket 0.03 square divided by 4. What do we have?
7.06.
We have that area is equal to what? 7.069 times 10 raised to power minus 4 meter square. Right? Now from here, let's get the ratio. Let's get the ratio of the length to area in section 3. What do we have? We have that 0.2 divided by what? 7.069 times what? 10 raised to the power of minus 4. Now, inputs, what do you have? 282.925. 282.925. That's all right. Now, so far in section 1, we've gotten the ratio of length to area in section 1, the ratio of length to area in section 2, the ratio of length to area in what? Section 3. Next up, we have to substitute each respective values, right? Okay, let's do that together. What do we have? The total elongation. Now, what's the value for force from the question? 15 kilo. We know that kilo is what? 10 raised to power 3. meaning that 15 times 10 raised to the power 3 divided by the Young modulus was given to be what? 200 giga Newton per meter square. 1 giga is what? 10 raised to the power 9, right? That will be what? 200 times 10 raised to the power 9, all into brackets. In section 1, what's the ratio of length to area in section 1? 159 point what? 134. That's all. Okay, in section 2, what's the ratio of length to area? Plus 2829.054. In section 3, we have 282.925. Now let's get the summation of this value. What do we have? That will be 15 times 10 raised to the power of 3 divided by 200 times 10 raised to the power of 9 multiplied by the summation of this. What do we have? 3271.113. Now multiply this by this. What do you have? What do you have? Let's get out. What do you have? 2 points. Your total answer. We have that change in length is equals to what? 2.45 times 10 raised to the power minus 4 what? What will be the unit? Meter. Why? Because we've been converting all our parameters, the given data, to what? Meter. 2.45 times 10 raised to the power minus 4 meter. But from what you have here, you can still convert to what? Millimeter. By saying 2.45 times 10 raised to the power minus 1 millimeters, which should give you in decimal. You have that 0.245 mm. You have 0.245 mm. Hence, the value of your total elongation for this question is what? 0.245 mm. Any questions so far? All right. In the next class, we'll be talking about thermal stresses and strain, which means that how temperature is being affected, or how temperature is affecting stresses and strain. All right. See you in the next video. Like, share, comment, and subscribe.